So, attractive forces. These are intermolecular forces between molecules. These are secondary forces that are weaker than ionic or covalent bonds. I want to emphasize that these are weak interactions, they are not bonds. Okay, these intermolecular forces are central to the stability of the macromolecules, proteins, carbohydrates, lipids, and DNA, RNA. So I want to emphasize that. We don't want to get these confused with intramolecular forces, which are also important, but these operate within molecules. And these also are seen in the macromolecules. So let's take the first one, which is dipole-dipole interactions. And these are the results of molecular polarity. We look at a CO bond, we know it's polar, we know oxygen is more electronegative than carbon, so we find if we have alcohols or amines, we know these bonds are polar, right? If these bonds are polar, we tend to have CO or NC bonds, which are also polar. So what we see is if we got a CO bond and another CO bond, we have this polarity here, a partial negative and a partial positive, and a CO over here, a partial positive and a partial negative respectively. So what we see is that these mutually are attracted to one another. There is an attraction between these molecules. And that's what we see as our dipole-dipole interaction. And this attraction is the result of differences in electronegativity, which produces polarity. That's critical. And as a result of this, these molecules tend to have higher boiling points and melting points than non-polar molecules. So that's critical as we think about that. In addition, we have London forces. We don't assume this with a, and these are what we see in non-polar molecules. And this is not permanent, but it's a temporary attractive interaction. The London forces become stronger with larger amounts of surface area and contact. This is facilitated by interaction, as you would expect. The more surface area, the larger the molecule, you would expect. So here is our carbon chain, our alkane chain. Next alkane chain, you can see the larger the surface area, the more interactions you're going to see, the more London forces you're going to see between these molecules, the greater that interaction is going to be, as opposed to something which is less linear but bent, such as these branched chains. There is less interaction of these molecules, so weaker London forces are observed. That is critical when we look at these macromolecules.